Hello. Hi, everyone. Myself, Saranya Nambiar. So I am here to talk about building a self-service Kubernetes platform using open source tools. And, I am a master's student at the University of Leicester, but I'm also interning at Tycoon as a product marketer. And that's my Twitter handle. The R is not there by mistake. It's a double R at the end. Before we talk about how to build a self-service Kubernetes model, let's talk about why it is important. So when organizations adopt Kubernetes, what happens is it becomes a bit of a bottleneck for the infrastructure team as well as the developers. And so to empower the developers so that they can deploy their own resources, at the click of a button, we should try implementing a self-service Kubernetes platform. It can also reduce the operational burden on the DevOps teams, as it's a strategic win-win, because when developers are deploying their own resources by themselves, the DevOps teams can focus on much better strategic tasks, and they can move forward happily. The next thing is that it also helps the developers innovate better and faster, and it accelerates the go-to-market time. So, what to expect from a self-service Kubernetes platform? So by building a self-service Kubernetes platform, it enables on-demand resource provisioning, which means that the developers can manage and deploy the clusters as and when they want. But with that, what happens is that we need to we need to manage and track the cost, the amount that we are spending on the resources. And the most important point that comes with this is, because everything is becoming autonomous, we need to ensure that we are enforcing the proper security policies. So we should have role-based access, and we should have automated policy enforcements also. Then, along with this comes the multi-tenant support. So if we are visualizing it in a large organization or even a small enterprise, what happens is when different teams or projects are accessing the same self-service Kubernetes cluster, nobody should be interfering with each other. They should always be isolated. So that is enabled with a multi-tenant support. And also, we should have built-in monitoring. That means integrated monitoring, observability, and CI/CD pipelines, so that teams can manage, monitor, and then deploy their resources without having any critical impact on anything. So this is a high-level architecture of the self-service Kubernetes model. So the UI interface is the UI layer is the interface with which the users interact. It can be a web portal, a CLI, or an API with which they interact. Then comes the access management. So as I said, the role-based access policies, the role-based access control, we have to check if that particular user is authorized to perform that action. And then comes the Kubernetes control plane, which is involved with the provisioning of the Kubernetes clusters. Then the most important, the star of this platform is the automation layer, Terraform and Helm. So Terraform is the one that enables in provisioning the architecture, and Helm is the one that automates the deployment. Then once all this is done, what is important is monitoring. So whatever we have done, we should always be able to ensure that it's not having a bad impact on the money. Because, for example, I've mentioned Prometheus and Grafana. So Prometheus is the one that will monitor the metrics, and with Grafana, you can visualize it. And then with the help of KubeCost, you can check whether it is going ahead of what you have planned, and you can you can help it. KubeCost can help you in reducing the cost. So, selecting the right Kubernetes distribution is really important. As I said, I'm focusing on open source tools. So I have kept into regard OpenShift, K3s, and vanilla, the basic Kubernetes. OpenShift helps us with enterprise-grade Kubernetes. So it has the developer-friendly built-in features. And K3s is the lightweight Kubernetes distribution. So whenever full Kubernetes stack is not required, that is when you can use K3s. So sometimes there are instances when my laptop cannot support a full Kubernetes environment. So that is the time when I use K3s. And then you can even choose vanilla Kubernetes. It is the pure upstream Kubernetes, and it is helpful for full flexibility. Then the next one in the pipeline, after this, is the automation tools. So you can select from Terraform, Helm, Argo CD, and kubectl. So it is actually the backbone, as I said, it is the backbone of any self-service platform. And Terraform, as everybody knows, it is an infrastructure as a code, so it helps in provisioning the Kubernetes cluster. Since it is cloud agnostic, it is fully flexible. Then comes the Helm package. So it is a package manager. It is the star of any self-service Kubernetes platform. It helps in the deployment of the complex applications, so it can bundle them into charts, and you can reuse it as it is versioned. The next one is Argo CD. So it is GitOps is the one which is a growing trend. So Argo CD, what it does is it ensures that your cluster state is the same as the desired state, which is mentioned in your Git repository. And kubectl is the command line tool, so you can interact with it. And since it is not strictly an automation tool, it is though it is not that, it is essential for troubleshooting and configurations as and when required. Now, implementing the security and governance is a very important part, because security, once you have developed the self-service platform, then you cannot think about security. So you have to do it as when you're building the platform. And the most important one is RBAC, because it assigns permissions based on the roles. It ensures that users and applications, they only have the permissions that they need and not more than what is required. The next one is Open Policy Agent. So it allows you to enforce custom policies across the platform. For instance, you can restrict namespaces. So if we create particular namespaces, we can ensure, as I said, it is good for different teams. So when we create namespaces, we can ensure that this particular team is not interacting with the resources used in the other team. So it is useful for that. Then next is service mesh. So you can add an extra layer of security by providing control over the service-to-service communication. And the last one is the secrets management. So you can use Vault or Kubernetes secrets for it, for storing sensitive information like access keys or tokens. Okay, the next one is monitoring and observability tools. So if we want to ensure that whatever we have put into place it is working exactly as planned, then we need to monitor it, and we need to make sure that the metrics are in check. For that, we have Prometheus and Grafana. Jaeger and Fluentd is also there, but I think more people prefer Prometheus and Grafana. And Prometheus and Grafana go hand in hand. Prometheus is for collecting the metrics, and Grafana is for visualizing it. Jaeger is for distributed tracing. So it can pinpoint to where exactly it has gone wrong. So pinpoint the root cause of the performance issues. And then last one is Fluentd or ELK stack. So what you can do is you can collect and process the logs from your clusters, and it helps with troubleshooting. So if you have to integrate, you have to put in a pipeline to integrate everything. you have to use Jenkins. It is my personal favorite. I've been using it for a really long time when I was working on some personal projects too. So it can simplify the CI/CD pipeline by automating the deployment. The next one is Tekton. So as I've written over here, it is a much more flexible tool, and it allows you to create customizable pipelines for really complex workflows. The third one is Argo Workflows. So it is designed for orchestrating the jobs across Kubernetes clusters. And the last one is GitOps. So as I said, it is a growing trend, and people are preferring it now more than ever. And it automates the infrastructure management throughout the Git repositories. And again, iterating on the same thing. So when we are trying to manage across teams or projects, we need a multi-tenant support. And for that, we have namespace-based isolation. So it provides the barrier that you need between two teams or two projects, and in technical terms, tenants. You can also, however, ensure that the resource quotas and the limits that are enforced, no tenant is crossing that, so that no single tenant is consuming too many resources. And then network policies, so that unwanted cross-communication doesn't happen. The last one is cost tracking. So KubeCost offers you to attribute only a certain amount of usage for a particular team, which helps in every team utilizing the exact amount of resource that they need, which helps in minimizing the cost. So this is an example that I've taken. Ticketmaster is a really big platform all across the world, which helps in gaining access to tickets for concerts, sports, events, or any events related to music or theater. So this is just an example that I've taken. It's not available anywhere. So what I've done is I've tried to make Ticketmaster give a self-service environment by incorporating all these tools into them. Okay, so the challenges. So what happens is when DevOps teams and developers are interacting with each other, and if there's no self-service platform, then everything is done manually. So manual provisioning of Kubernetes resources, which creates delays and bottlenecks. A developer has to go to the DevOps team, and then they have to create tickets, and they have to see if the infrastructure team has done it properly or not. Has the ticket been resolved, like whatever I've demanded, is it done? It creates a big bottleneck. Then the development teams face inconsistencies across all the environments. So the solution is building a self-service Kubernetes platform. So this is an architecture that I've made. If we are trying to implement the solution that I'm giving at Ticketmaster. So there are 4 phases when the platform is built. We'll get into that later, but the self-service portal, how it will look like is, there will be a UI with which the developers will be interacting. Now, so with which the developers will be interacting. Terraform will be used for provisioning the clusters, for making the infrastructure. Because Ticketmaster currently uses AWS, managed Kubernetes, so I haven't removed that part because that will take some time adopting from a managed Kubernetes service to an open source or an on-premise Kubernetes. That's the reason AWS Cloud is there. And once this has been done, then security. So for that, we can use RBAC. And for secrets management, we can use HashiCorp Vault. And for managing the application, we can use Argo CD. And for the package management, we can use Helm. Once this is done, then we can move forward to monitoring it, and for cost management, for that we have Prometheus and KubeCost. Now the implementation that I was talking about, so first it will be a pilot phase, like they will be launching it, and then they will be testing it across a small team to ensure that what they have visualized, it is happening properly in reality. And then they will make it as a standard protocol within their company, because it's a very large company, so we cannot scale it all over the company and then create havoc within the company. So that's why the second step will be team scaling, and then it will be standardization, and then the next step will be optimization, because based on the on-ground situation, they can then they can change the metrics, they can change the parameters, bring some changes, go forth, and then bring changes, and then it's like an agile situation. So for that is the phase for optimization. And these are the tools that I used over there. So as I said, the impact will be developers can innovate faster. So it can increase the developers' productivity, operational efficiency gains. It can keep consistency across different environments, and cost. Major impact will be on the cost, because we are implementing KubeCost into it. And these are some, so I'm going to present some real world case studies, not go into depth because it is already there on CNCF's website. But they do not have a complete self-service Kubernetes platform. Certain aspects of the platform have been implemented into their company. So one such company is Rabobank. It's a multinational bank. And the next one is Mercedes-Benz. These two, as I said, have only certain sections of a self-service Kubernetes platform. And then this is the company that I'm interning at. So the company is an advanced Kubernetes, advanced managed Kubernetes service. So one of its features is a self-service platform where you can go and you can connect any cloud provider with the company's platform, which is CloudWorks. And then you can make different users and you can give them their responsibility. It can be a manager, admin, and then those people, like those users, can create their own clusters. The admin obviously has an overall view of what is being used and how much to track. We also have vCluster on our platform, so you can have the multi-tenancy support in it. And it has a chargeback model, so it allows you to only have the amount that you use, only that much will be charged. And this is dashboard. So the dashboard allows you to have a complete view, as I said. And in that, you can see what are the repositories that are currently in use or which are made. And as I talked about, you can see the users, which user has which rights. And if you go in the section called Tycoon Request, you can see who has accessed which particular page and what did they do, and how long ago was it. So if you have to get started with your own Kubernetes self-service platform, then I would suggest starting small, only implementing the key open source tools that is required, focusing on automation and security, monitoring and optimizing, because if it doesn't work, you have to go back and then check what will work for you, and then build developer-friendly UIs, because what simple works, people understand it better. And yeah, that's it. Thank you for listening.